All right. Good morning, everyone. Happy week 3. Can't believe it. We are already, well, not quite a third, almost a third of the way through. Amazing. And I just tripped over a green screen behind me. This room is not made for pacing. Anyway, how is everyone? I hope everyone has had a good weekend and is ready to get back into it. A bit more coding, a bit more fun, and lots of stuff to talk about this week. Today in the chat we've got Tom and Sophia as usual for a Monday, so please pop your answers too, but questions in the chat and we will begin. Let's begin. Oh, I'm forcing you to say hello twice. It feels like everyone's just woken up. Is everyone's just woken up? Or is it just in this room everyone's just woken up? Well, I've been here since early, but my computer took like 45 minutes to decide to regenerate this morning. So, all right, let's get started. Oh, that's right. This is the after maths lecture. Oh, every time I'm burdened with this. Sophia used to have a maths lecture and it was 1 till 3 on a Friday, and then she'd come to my lecture 3 to 5 on a Friday. So I guess we should be thankful we're not at 3 to 5 p.m. on a Friday. All right. So last week we talked about sorry, we've got this huge monitor working and the chat is now on this humongous monitor. Someone should really put a photo of this setup in the forum because it's the TV working today is amazing. And I can really see the chat now. So lots of people are asking about the message cipher. It's a special exercise and you can ask questions about it on the forum. There we go, and then you will get answers. Forum people are going to be back on today in great force. All right, so last week we talked about making some decisions using if statements, and we talked about conditionals, so different ways that we can make those if statements and how can we put it all together. We did some loops. We looped the loop with loop and while, so we did the while loops. We talked about scanf and how eccentric it is and what it is, how we can stop it from making errors, or how can we make it be nicer for us. And then we also started to learn about structs and enums, which was quite nice. Okay, so someone doesn't understand why we're returning 1. We can talk about it today, all right? So don't worry, I'll explain why you would return something else. So don't worry, we will return different things today as part of functions so that you can see it all come together. So today we're going to talk about functions, finally. I have mentioned the word functions about 1,000 times starting from, I was going to say week 0, but did I mention it? Maybe in the welcome video I said functions as well. We're going to talk a lot about functions today. We're finally going to learn how to decompose things into functions, and then we're just going to, just have fun with it. Someone saying assignment 0, stage 3, it will come out during this lecture. Should have been out at 9 o'clock. So, yep. There we go. All right, and then we're going to talk a little bit more about style because we've kind of talked about it a little bit here, a little bit there, but we're going to look at how bad Sophia. Then we're going to look at what bad style looks like and why we would not do bad style, why we want to have nice style. Okay, let's have a look. Okay, live lecture code, if we can pop it into the chat. LP wants to know why we have a week to complete previous stages for this time, but only 5 days for stage 3. The previous stages are there when you don't know how to code at all, so that's why you have a week for each one of them. And then the reason this one is due on Friday is to give you a rest over the weekend before you start assignment 1, before assignment 1 is released in week 4, because you do need a break. And we made the assignment a lot easier because of that, so that you can actually get the stage 3 done no problem. Yeah. Okay. And let's continue. Let's start to look at functions. Fantastic. Let me just check the chat. Anything on the chat? No, all good? Okay, excellent. Yes, you can do assignment 0 without structs. Yeah. Okay, no worries. All right, so far you've actually already been using functions. You've been using them a lot. Oh my God. Okay, so far you've seen me use printf, which is a function, and you've seen me use scanf, which is a function. So they all, they are all sitting inside the standard library, the standard input-output library. So if you go to actually look at the code, you can see that they actually have code attached to them as well. And then obviously our main that we've been writing everything in so far. We've been putting everything into the main except for when we looked at a procedure and we kind of took a chunk out and put it outside of the main. But what does it actually mean to have these types of functions, and why do we do it? So let's take a quick look as to what they actually are and why on earth we do functions. So basically, when you have someone said, I did assignment 0 in 300 lines, so thank you for providing me with that example. Is 300 lines of code inside your main function? Please don't tell me you used functions, because that will make my example obsolete. But let's say you've got 300 lines. Let's say you've got 1,000 lines of code, 2,000 lines of code. Imagine having all of that inside the main function. I mean, that is a nightmare for a human to read. And what do we create code for a human to read? The machine executable file is created when we compile, so it's not for humans. But when we write our C file, that is actually for humans. So we want it to be neat. And what functions allow us to do is they allow us to break down those 1,000 lines of code into something much smaller, because it allows us to have smaller components, and where each of those little components will do some sort of function. And what it means is you don't have to repeat code, because what you can do is you can just call that function whenever you need. So let's say you have a function to add 2 numbers. Anytime you need to add 2 numbers, you just call that function. You don't even have to worry about it. The same way as when I need to print something out, I just call the printf function. I don't need to write the code for print something out to terminal. And anytime I take something out of terminal with scanf, I just call a scanf function. I don't need to write the code that will, take something out of terminal and will do everything that is associated with it. So that means what a function allows you to do is it allows you to decompose your code, and it allows you to make it look a lot better and read a lot better. And it allows you to be lazy, because you can just keep calling a function every time you need to do, a duplicate function. So each function has an input and an output, which I have sort of briefly mentioned, but haven't gone out in detail. But just because you have to have an input and an output doesn't mean that that input and output can't be nothing. So you can have input of nothing and output of nothing. As we've seen, a procedure, the output is nothing. That's what makes it a procedure. And we've seen the printf, it just prints out to terminal. It doesn't really return anything to us. So when we call a function, we can call a function from anywhere in our code. It doesn't just have to be in main. You can call a function from a function from a function. You can call a function from anywhere you need to use it. And what it does is when it gets called, and I'll show you in an image, but once you call something from a function, it goes to that function, and then when it finishes the function, it will come back to the point you called it from with a return, and then continue onwards from there. Okay, so let's look at the structure of a function. Okay, let's say we've got a little function that adds 2 numbers together and returns the result. So we've got the first keyword is the return type. This is what this function returns, and we have kind of looked at it briefly. you can have anything there. You can have an int, a char, a double, whatever the function is returning, that's what you have. So based on what it is you want to send back to the function that you called it from. Then we have the name of the function, and the name of the function is whatever you want to call it. So, you know, whatever it is, that's up to you. So I'm seeing a lot of stage 3 of assignment 0. It's about to be made available. Okay. Yeah. It's going to be released in the next probably 15 minutes. Okay. And then inside the brackets, inside your round brackets, we have your inputs are arguments. So this one has 2 things because I'm sending 2 numbers to be added together, but you can have different things. You know, you can have chars, you can have doubles, you can have whatever you need to give the function to perform, right? To perform whatever it needs to perform. So you've got your inputs or your arguments here. What are you giving the function? And then the curly braces denote the actual function itself. So in this one, the point of this function is to add 2 numbers together. That means I want to return the result. So I'm returning the sum, and that means I use my keyword return, which means that this is not a void if I'm returning something. And here I'm returning a sum. A sum is an int, and that's exactly what I said I will return. I said that I will return an int. If my return type is void here, it means I haven't returned anything. And that means the function is a procedure, right? So the reason that you have procedures and functions, lots of people are like, well, why? They're really the same thing. One just doesn't return something. So that is true, but there is a reason that we differentiate between the two. And that's because sometimes it's safer to write a procedure as opposed to write a function, because once you start returning things, there are possibilities for things to go wrong, and there are possibilities for quirks to happen, for garbage to appear in memory. So there's possibilities for things, for security vulnerabilities, and for things to go wrong. So we literally just differentiate between the two to allow us this ability to have a function that doesn't return anything. And it's quite, you know, that's a safer function than constantly, but it doesn't mean, in C, a lot of the time we really refer to everything as a function. So don't worry about knowing the 2 separate terms for it. It doesn't as much impact you yet as it will later on, but just know that you can return nothing. And you can give it nothing as well. You can be super mean. Don't give it anything and don't ask for it to return anything. Okay. So let's write some code, and I'm going to write all the code inside my main function because that's the kind of person that I am. And then what we're going to do is we're going to work together to decompose it so we can see how functions are made. Okay, let's do it. And then what I'll do from here on outwards, because that's not how you're meant to do it. You're not meant to just write one big chunk of main and then decompose it. After we decompose a function that we've written in the main, then we're going to start writing code where we think of the function before we start writing the whole main thing. Okay, let's do it. So the problem is, take in 2 die rolls and check whether the sum of the dice is equal to the target number. You win if that is the case, and we might extend the problem, and otherwise you can roll again, so you'll keep rolling kind of thing. Okay, how can we break this problem down? Let me go to the code because it's easier. Here we go. All right, so what do we need to do in this problem? Ask the user for the result of the rolls. Excellent. Yeah, that seems reasonable. We might scan in the 2 dice, and then we add the 2 numbers together. We'll check the sum against the target number, and then we'll output the result against the target number. So are you winning or are you losing? Okay, and then we're going to break it up and decompose it into functions, and we're going to talk about, you know, how not to actually just write giant chunky code and then decompose it, but rather start thinking about decomposing it straight up. Okay, let's do it. Okay, so first things first, let's ask the user for the result of the rolls. Okay. Okay, so I guess we need 2 rolls, so we want 2 variables to hold our rolls in. Okay, great. Now we want to ask the user to give us what the roles are. I don't know why it's taking me so long to do a spec. I'm really distracted by everything. Okay, great. So now we need to take in two things. So let's take in two. And what are we going to take in? What's going to be an int, a double, a char? What are we taking in? Who knows? Yeah, we're going to take in two ints. Excellent. Let's take in our two ints. %d. So I'm going to take a %d and I'm going to take a %d. 2, and then I'm going to pop them inside first one, and don't forget to do your ampersand. We're going to pop one into die 1, and then I'm going to pop the second one into die 2. Excellent. Okay, I've got two roles. I've popped them into here. Now I'm going to also do a scanf return here because I want to know that scanf has returned something. At some point in time, at one of the steps, I also need to add the two numbers together. So I'm going to need an int sum as well to keep hold of the two things that I'm adding together. Okay, so what should we do next? We've taken in the two dice rolls. We've got the two numbers. What are we going to do next? What are we going to do next? Lots of nice questions. Yeah, okay. So we're saying add them together. Okay, yeah, we can add them together. I guess sum is equal to die 1 plus die 2. We won't do functions yet. We'll do functions in a second. We'll just write the code for this first so that we can see how to break things up. Okay, and then what should we... And my Siri, I'm not sure what's going on, but the first thing that she found is Bible's Hidden Messages Part 3. Breaking down the something, who knows? 12 Bible verses about giving. I'm not really sure what's going on, why that discussion that I was having that's the search. Yes, good. Someone is saying I should do an error check. I like that. Yeah, that's very nice. Yeah, so great. Well done. So there's really two things that I can check for. I should check that two numbers were given. Okay, that scanf return is equal to 2. And I would also check that my die numbers are between 1 and 6. Yeah? Because I can't really have a number greater than 1. I can have greater than 1. I can't have it greater than 6, and I can't have it less than 1. Okay, how would we do that? What do you think if I do if die 1 is less than 1? And then I'll do another if die 1 is greater than 6. What do we think of that? Yeah. Well, will we use or and? So if you think about it, what I've done here is I've created a nested if, okay? I'm nesting my ifs. Now what will happen in here is that if die 1 is less than 1, so if that's true, it's going to go in here. And if die 1 is greater than 6, then it will go in here. Okay, so this will be some sort of error message because they wouldn't be happening. So one of the issues with bad styling, and I'll just keep mentioning it, is when you have these nested if loops, and you don't really want to do that you really want to just have a conditional there to include it. One way to break down the if loops is to have and not to have it nesting so much. It's bad coding to nest so much, because when you start nesting, that's when mistakes are going to be made over and over again. So what you want to be doing is you want to be listing out the potentials on the same line. So if die1 is, I'm going to go the opposite way, like if it's true. If die1 is greater than 1 and die1 is less than 6, but it's also going to be equal to, isn't it? So this is much better style to create a one-line situation with a conditional, because no, so I'm just going to go back. So I'm going to explain the difference between DCC and GCC because someone's asked. Sophia's almost right, but not quite. GCC is a compiler in itself that uses a few other things. But DCC was written in-house and it calls about 3 other packages, not just GCC. It checks for a lot more things that GCC can check for, because GCC is just your basic compiler. It's not built on it. It calls things, which you wouldn't know unless you read the source code, which I don't recommend you do. But yeah, so the one part that Sophia got very, very right is that DCC is made to help you code better. It gives much better error messages, and it allows you to know what the hell has gone wrong and how you can fix it. And I don't know how many of you have used GCC, but the error messages are not as good. It gives the output and then it gives the DCC output, which is a lot better. Okay, Ivan, we cannot write that. We have to it has to have the conditional on each statement. It doesn't know how to do the maths type 1 if it's between 1 and 6. It has to be... So DCC is not, it's tailored to novices using C. Whilst you are at UNSW, you will use DCC. And in your other courses, you will use DCC also when you're writing code in C. It's made for us to be able to teach C as the first programming language, which can be a hard language to learn to start with. But I don't know. You can, DCC is open source, so you can build it outside of university as well. It's open source and we do make it available for students. It's a bit hard on a Mac though, so yeah, parts of it are broken. Let's not talk about it. Okay, so if die1, careful of the cord. Okay. Back to this. That was a distraction. I'm sorry. Okay, so first one. If die1 is greater than 1 and die1 is less than or equal to 6, then we're okay. But really, we want to check now that die2 is also doing the same thing. I'm going to nest a little bit in here, just for fun, and then we'll talk about that as well. So I'm going to say the second condition has to be true as well, and die2 has to be less than or equal to 6. Okay, in this case, we are rolling. We are all okay. The dice are good. So that's when we're going to add them together, when they are legal to be added together. So I'll cut that. And let's go in here and I'll paste that. Yes, we can do it all in one statement. That's why I said I'm doing it for now like this, and then we're going to change it up, okay, when we look at style as well, because otherwise it becomes quite hard to read as well. So we will, don't worry, we will unnest it. Okay, excellent. Now, what happens if I decide to enter just one number? What if I put in just 1 here? So what happens over here? What happens if I just enter 1? What else can we do here to safeguard from that? Thoughts, ideas, suggestions? Yep. Yep, let's check scanf. Okay. If that scanf return, so whatever the scanf function returned to me, is not equal to 2, then I know that I can't really do much. And I'm going to print out an error. I'm just really using this as an opportunity to show you what return 1 does now. Okay, printf, you did not enter 2 numbers. Program will now exit. Amazing. Okay, great. So I'm checking the opposite is true. I'm checking first up, if it's not equal to 2, I'm just going to exit out of it and that's it. So I'm not going to wrap everything else into my into my statement if it's equal to 2. And this is when I'm going to return 1. Okay, so prior in the lecture, someone asked, why do we return 1? What on earth does it mean? Why am I doing it? So you have seen time and time again me returning 0. And I've said, okay, this function, if you remember, the first thing in the function is the int, the first term, and that's the term that says that what you are returning. Int means I'm returning an integer. I'm returning a number. I can really return anything in there, any number that I want. I could make it, I don't know, 50, 60, 70, whatever on earth I want. As long as it's a number, I can return it. But, okay, standards wise, you return 0, so you return this 0. If the program has finished running successfully with no issues. That's when I return a 0 to say everything is done correctly. That 0 goes into another space to show me, that everything has been okay. You will not use that space in 1511, but it's good practice. Now, when I return 1, what I'm saying is that something went wrong, okay? So return 1 when you finished running, but with issues. So it's like a failure of program. Either I left the program early, I didn't run the program. So the 1 can later be used for debugging when I can see what my program is returning and which paths it took. So all it means to return 1 is that the program finished running and there were some issues there. And then here, returning 0, the program finished running, there were no issues there. But you can also return any other number, which we will learn how to do in our functions in a second. Okay, so there's some good questions there. Yeah, so scanf return. There are 2 input values, both are true. So okay, scanf return is the number of things that it scanned in successfully. Is the return value of the scanf function, which says how many numbers were scanned in successfully. Okay. How does the value know? It doesn't right now. Well done. I haven't assigned it anything. Okay. So this over here should really have a scanf return and then equal to. So now I'm assigning it whatever this is returning. Okay. And now it's going to have a value. And we would have realized that when we've run it. Yeah. Well done. Okay. Good. So now we've added these things together. Now we need to check the sum against the target number. Okay, if I have a target number, I know that I need to hash define it. It's never going to change. So I'm going to hash define a target. I don't know, give me a number. Something between 1 and 12. 11. Tom's saying 11. Let's make it 11. I feel like I'm in a bingo room. Legs 11. Don't know if anyone's ever been to bingo with their grandparents, but that was the 11. Okay. Oh, hard 8. A 7. An 8. I feel so pressured to change the 11. No one wants 11. There's 3 votes for 8. 8 it is. Sorry, Tom. You've been usurped. Okay, let's check. Oh, look at that. Someone's coming in to back you with 11. Beautiful. Okay, so now let's check. Let's check if it's all good. Okay, so if sum is greater than target, then we're going to print out the sum of the dice is greater than the target. Okay, great. Else, if the sum is less than the target, then I'm going to print out the sum of the dice is less than the target. And my third condition, I assume, is that it would be that they're equal. Okay? Okay, so I'm going to say have an else condition for when they're equal. And then I'm going to have a printf here. What is going on? My nails? I don't know. Okay, and you are on the target. Okay, fantastic. Good. Okay, and that's it, really. How do we feel about all of that? We feel okay? Let's try and run it, really, and see how the compiler feels about it, which really is the most important thing. And then, Tom, could you please run a poll how we feel about this, what we've written so far? Oh, what is happening in here? A lot is happening in here. Variable sum is used uninitialized. Oh, yeah, okay. So always when you get the errors, always look at the first one, fix it, and then you can keep going, okay? So what is happening here and what this error means is over here I have an int sum, okay? And what I do is in here before I do anything, so I've got my blah, 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 I've got here sum is equal to die1 plus die2. But what happens when this is not the case? What happens when we just pass out? How do I compare things? How do I make it happen? Whenever it says uninitialized variable, it means that somewhere in your code it's been used and it doesn't know what it is to start with on the very first time. So initializing your variables is a good practice and DCC picks it up, but often GCC doesn't. Okay, here we go. Look at that. It fixed everything. So dice. Oh my God. I do not know what's going on today. Okay, let's do 3 and 4. So that's 7. Sum of the dice is less than the target. Yep. Let's do 4 and 9. Can't have 9. It should exit out of it. Ooh. That's awkward, isn't it? Isn't that awkward? That doesn't really work, does it? Because 9 is a really awkward number. Okay, so we've got a mistake somewhere and we'll have a look at it in a second. Okay, excellent. Let's run it again with the target. Yes, good. The target works. And let's try another one that's in the vicinity. 5 and 5. Greater than the target. Okay, so those work. Okay, fantastic. But something doesn't work. So I broke it by saying, okay, what if I do both of them outside of the scope? It's saying the sum of the dice is less than the target, which is crazy because 1, that's equal to 14, and 2, that's not really valid. You can't have a 7 on a dice. So what do we got? What should we do in here to make sure that this is only happening if the dice are legal? What should we do? What do you reckon? Should we maximize the dice values? I don't know what that means. I'm not sure what that means. You might have to clarify that. What do we reckon? Oh my gosh, we haven't even made a function. It's happening. I move at the speed of light. Where did I initialize? In hash define. Over here. Yeah, that's a good idea. What about here? I've got if die1 is greater than, say, if die1 is greater than 1 and die1 is less than 6 and if die2. So here I've got this condition that's checking it's all correct, then it's adding it, but there is no else, right? So what if I say else? I'm going to exit out of here. I'm going to give an error message. The dice values are not legal. Okay, just ignore the spelling mistakes. I just can't seem to. And then I'm going to, oh my, and then I'm going to return 1. Okay, let's try it out. Let's compile it again. And let's run it again. And now let's do a 7 and a 7. The dice values are not legal. Great, we've caught that error now. Yeah. Okay, let's, everyone is struggling on a Monday morning, it seems. Okay, let's have a look at breaking it up now, because really the point of me doing this was that you get a bit of practice writing this code, but also to break it up into functions. Let's break it up into functions. Did I make a typo somewhere? Yeah, I did. Of course I did, yeah. Okay, all right, there we go. Everyone happy? Okay, if we enter letters, someone asked a very good question. Let's do an R and an R, and it will catch that out, okay? Because it's looking for %Ds. It's not looking for, so it will catch it out. Yeah, good question, excellent. Okay, so let's try and break this up into functions, because why not? Let's live a little. Okay, what should we do? Which function? Who wants to break it up? This is looking a bit messy, it's looking a bit long, there's a lot happening. Why on earth is this, there's a lot going on here. Let's break it up. What should we break it up to? What do we want to break out of here? I've used this example of the 2 dice being added, so why don't we break that out? Okay, why don't we make this a function to start with? Yeah. Okay, so I want a function that will add 2 things together. Okay. Okay, great. So I'm going to have an output to the function, I'm going to have an input to the function, and then just because I'm going to have a name. Okay, what will the output be of a function that adds 2 numbers together? What is it going to be? Is it going to be a char? Is it going to be a double? Is it going to be an int? What are we returning? So the output is going to be an int. It's going to be the result of adding 2 numbers together. What do I have to give the function when I'm adding 2 numbers together? I'm going to have to give it the 2 numbers, won't I, of the 2 things that I wanted to add together. So I'm going to give it an int and an int. I'm going to give it the 2 numbers that I want to add together. Excellent. And then name, whatever. Well, it can't really be whatever. I can't call it something random because that's not very good style. The way we name a function is based on what the function is actually doing, because then it allows us to easily breeze through code and see what is actually happening in that code. So I'm going to call it sum, okay, because why not? That's what a sum is. Okay, so let's do it. So the output is int, so I'm going to write int. The name is sum, so I'm going to write sum. And then in round brackets, I'm going to write what I'm giving it. Okay, so I'm giving it two things. I'm giving it the first int, and I'm giving it a second int. Wow. And then I'll do my curly brackets, and I'm ready to go. So when I give it two numbers now, and what's my function going to do? It's going to give, I have to have an int sum is equal to 0, and then I'm going to say sum is equal to number 1 plus number 2, which are the two things I gave it. And don't worry, I'm about to go through it in more detail. And then when I return, my output is meant to be the result of adding those two things together. So I'm going to return the sum because that holds the result of adding the two numbers together. Okay, my function is called sum, and I'm going to call it from this main function here instead of doing this. So in here, I'm going to call the function called sum, and I'm going to give it the two things I want added. I'm going to give it die1, which is the first thing I want added together, and die2. So I'm giving it the two things that are going in there. That now means I don't need this in sum here is equal to 0, but we'll see if I need it or not. Okay. Let me go through it with a pen just so you know what's going on. And what I'm going to do is I'm going to extend this screen and then I'll make it smaller again for the compiler just so that you can see exactly what's going on and who's returning and where things are going. So what's going to happen here is it's going to go down to this point here where it's calling the function on line 43. Okay, so it's going to go down to line 43. Move this out of the way for you. And I really need to just go. Okay. Oh, God. Okay, so we've gone down to line 43 over here and we've called sum. What's going to happen in your code is as soon as it sees this function, and right now it's not going to do that, but it will find this function called sum and it will check two things. It knows that sum needs to give it two things, so it's going to check that you've given it two things. It's going to check, are they the right type? Because here you've said that you're going to give it two ints. Is die1 an int? Yes, it is. Good. Is die2 an int? Yes, it is. Excellent. So whatever values went in here, so for example, let's say I entered 3 and 4. That means die1 is 3 and die2 is 4. What happens, what it does is when it goes down here and calls this sum, it makes a copy of these two variables that you've given it here. So what it does is it says, okay, I'm now in here, I've given it two things. That means number 1 is equal to 3 and number 2 is now equal to 4, same as these two over here. It's going to say sum is equal to 0 because that's the next line over here. Now sum is equal to number 1 plus number 2, so sum is now going to be 3 plus 4, which is 7. And then it's going to say, okay, return sum. So return that number 7. Where does it return to? It returns it to line 43 where you made the call from. But right now, what is happening here is you're not storing that return. The return is just coming back, but you haven't got it going into anything. So one way that you can store the return, and we're going to look at a few ways to do it, is that you can say that you would like And this is going to get really confusing because now they're called the same thing. I'm going to recall it something else. Okay, so it's going to store the result of that, the return, into int sum. Now this int sum here inside your main is not the same int sum that's here, because a variable lives and dies within the curly brackets. Okay, so this sum really lives in these curly brackets, and when it's returning sum, it's really just returning 7 in here. It gives 7 on this side and places it inside whatever variable you want to in here. Okay, this is an excellent question. Since the compiler reads top to bottom, do we need to move the int sum function to the top? Otherwise it won't know. That is a really good question, and indeed, it does not know. It will not find it. If I compile it right now, what it will tell me, and I'll show you what it will tell me, is it will tell me, you're mad. I don't actually know that something like this exists, so I don't really know what to do. So as soon as I compile it, it's saying to me, great, you already have a variable named sum. It's confusing to have a second overlapping declaration of the same variable name. So there's a whole bunch of things going on because I've been calling a few different things. It's not giving me the error message that I want because it just stopped reading on that error message, which is quite annoying. But what I can do is not have int because I've already declared that I have an int. And if I do it now, it will give me the error message that I want. So let's run it. And this is the error message. Implicit declaration of function add is invalid because you're calling a function named add on line 43, but DCC does not recognize add as a function. There are several possible causes. You might have misspelt the function name, you might need a hash include line at the top of dice roll, or you might need to add a prototype for add. Okay, so let's see what this means. This error message is the error message that you will get when you write a function, but you don't actually, you write the function underneath the main and you don't tell C that this function is coming. It will not know that it's to be expected. So let's decide what a prototype is. A prototype is really a copy of this, your definition of the function. So it's that front line, it goes just before, just outside your main. Okay, so if I paste it in here, and all you do is put a comma, a semicolon behind it. So all it is once C starts reading, this is called a function prototype. And what it tells C is that this function is coming. You should look for it, other than telling me that I'm lazy and haven't written it. So in this way, you avoid getting that error message. So if I run that now, it's going to compile okay because now it knows that that function exists and it's somewhere below the main. It's also a nice thing to do when you're just reading through everything because you can see what functions exist. So all you're doing is you can also just have the function above the main, but the reason we don't do it is because then it becomes quite confusing. If you call a function within a function, does that function come before the function that you need? And then you start to get very confused where you start calling functions upon functions. So it becomes a very messy process if you do it like that, which is why we use function prototypes. Then it doesn't matter what order your functions are in underneath the main, because it knows that these functions exist, so it's not going to complain at you. So whilst you can do the whole function before main, once you have 50, 60, 70 functions, it starts getting very, very confusing, okay? Because you don't know who needs to be called first because they need to come in order. Okay, and that's why the prototypes. Okay, how are we going for time? Do we have time to separate something else? Let's separate something else out into a function. What should we separate out? Thoughts, ideas, suggestions? Should we separate out the comparison? That's looking a bit ugly, this bit here. Oh yeah, we can do the input. Should we do the comparison first, then we can do the input as well? Okay, let's do this one first. Let's separate and then we'll do the other one. Let's make this a function. Okay, great. What do I need? Talk to me. You know what we need? We need to erase the red. That's what we need to start with. Okay, let's make the comparison a function. Okay, first thing, what's my output of this function? What's the output of a comparison function? Yes, well done. It is indeed a void because I'm just printing stuff out here. I don't actually need to return anything. I'm just printing stuff out to terminal. So I don't actually need to do anything. Well done. It's a void. I'm just printing. Okay, what about an input? What do I need to give it as an input? What do we reckon? What's going to be my input that I give it? Yep. Yep. Okay. So it needs the target and the sum. And this is one of the reasons that we define, and this is such a good, oh, thank you for saying that. The hash define is sitting outside of the main, okay? And because it's sitting outside of the main, it is available to everything that comes underneath it. So it's not a local variable. It's a constant that's available to all of my programs, which means that I don't need to give it my target. It can see it by knowing what this hash define is. So all I need to give it is the sum, but it can see the target itself. So that means all I need to give it is the sum, and it's an int. And then the name, I don't know, compare. So very clever. Okay, so let's do void compare. So void my output here, then the name of the function, and then I'm going to say what I've given it. Okay, great. And I'm not returning anything, so I don't really, now I'm going to take this out. And I'm going to place it here inside my function. And that is really it, isn't it? What else should I do? I need to call my function probably, don't I? So I need to call my function. I call my function by its name, just like you would call your friends by your names. And then you tell it what you've given it. And I'm going to give it this sum thing because that's where I've popped my sum into over here. So I'm going to compare sum, and that means it's going to call that function. And that's, I'm not returning, so it doesn't need to, it doesn't need to return anything here. It's just going to come back and continue reading. Okay, let's run it. Or what else do we need to do? Let's run it and see if there's anything that we're missing. There well might be. Oh, here we go. What have we got? We've got the same thing again, okay? And, oh my God, this mouse. I hate this mouse. Okay, so it's saying you might need to add a prototype. And that's because I haven't told it this thing is coming. I'm just using it. So you take the definition of this function and also move it to the top outside of your main to tell it it's coming. Okay, and then the semicolon behind it to say that it's coming. And then let's run it. Okay, and let's check that it's working. Excellent, so it's all working. Yeah. So good question again over there. Isn't it easier to leave the comparison logic in the main function if we're only going to run it once? Yes, in this case, but preparing for extending the problem, for example, rolling again and again if you haven't, fixed the target, so then you'll be checking again and again. So what happens if we do want to do that? What happens if we want, we're on 12 o'clock, we're almost ready for a little break. I'll just do this and then we'll do it. Actually, no, because then I'll take forever to do it, as per usual. Maybe this is a good time to take a little break. Tom, can you run a poll whilst we're taking a break? How are we feeling about functions? And maybe we will do more functions when we come back, and then we'll do a little bit of style to finish off with, because it's more important that we kind of get a good hang of functions. As Sophia said, we want to have as little as possible in main. That's what we work towards basically removing everything from the main except for calls out to other things. So main becomes your lazy function. All right, let's have a little break and then we'll be back in a tick. All right, let's let's Kahoot. Just to wake everyone up and give them a little bit of an oomph after those functions. There's stuff happening outside the window, which is a bit exciting. The Sunswift car is getting a...
It is.
Oh. I thought Tom was looking at the Sunswift car with loving longing. He wants to be out there through the dirty window. No, he just said he'd rather be in the lecture. Wow, on a Monday. Well done. Your job is safe. Who is going to win today? Oh, can't believe it. Oh, Sophia and I are starting to feel left out. Why isn't the music playing? What's it doing to my music? It's killing me. Should I make Tom sing? All right. What's happening? Music? No music? Someone's gonna have to sing. Oh my gosh, that's going to become a meme. That's a very witchy laugh. Okay, fantastic. Let's do it. The code should be available. Okay, let's start. Let's start. We ready? Oh, I've just blocked it. Unhelpful. Okay, very good. Very good. Most people got that right. Okay, next one. Okay, okay. Can you see this one okay? On your screen. Oh. Nice. Or not nice. Okay. loop in the loop. We need to go through it again. Okay. All right, a few things we need to go over. Okay. Okay. Last question. Oh, shoot. Unhelpful. Okay. Let's see who's on our podium today. I wish you would play me the music. It's okay. It's okay. You've tried. I don't know why it's doing that. And number one today with 4 out of 6. Oh, Sun Swifty. It's not Tom. He's saying it's not him. Very good. Well done. Okay, should we, and now a few people have asked on the feedback to go through them. So should I go through them? How's everyone feeling about that? There were a few wrong. That's usually how I make my examples for my next ones. Yeah, I don't think I'll be going through it because it's hanging. Even the computer didn't like my Kahoot. Are you hanging? Or is it just me? Just me. It's not responding. It's Monday morning. It's had enough. It's done. It's done for today. All right. We might have to wait to go through it whilst I reload it all. If I don't go through it today, we'll do it on Wednesday morning, okay? So don't worry, we will go through the answers. And I will also include some of the examples as well. You know, I will include what people got wrong in my examples so that we can go through things a little bit more solidly, because it looks like a few things we need to repeat, which is good, and we can do that. Okay, so let's go back to talking about functions. I think Tom was running a poll about functions. It's looking okay, actually. Functions are looking good. Should we have some fun with style maybe then? And then, don't worry, we're going to keep doing functions from now on. So, and we're going to repeat a few things as well. Or if I can just get that Kahoot to work again, I'll quickly go over the Kahoot. Just wait for it. No, that's just hanging now. Can I force quit it? I didn't mean to do that. All right, I just force quit Safari, which also closed my window. Anyway, I can see the chat. Thank you, Tom. And then, yeah. Okay, let's do style. Why not? All right, here's something that I prepared earlier for you. And we'll talk about a few of the things that you got wrong in the Kahoot as well. How's this looking? Is everyone excited? Does this look good? I didn't even know what errors I made in it. I literally just wrote some code and then I made it look bad. What do we think? Does this look good? Easy to read, easy to understand? Does anyone know what this thing is doing? Something about ice cream. Does it look nice? Yeah, bad indentation, just the start of it. There is, yeah, so much more bad in there, okay? What are we... Yeah. Yeah. Just want you to look at it in the screen for now. Here, you can look at it on your own if you like. Not going to be able to run it because I've made it just... Yeah, there's inconsistent white space. What other issues can we see? We can see bad indentation. What else can we see? What else is looking good, looking not that good? Missing brackets. There are some missing brackets. Just a lot happening. Yeah. All right, should we go through and try and fix it? No, return 77. That is pretty random, isn't it? I can see some nests. We don't like a bird nest in our hair or in our code. Absolutely. So this is part of the reason why we style code. No semicolons, I bet. And that's because if you don't style it, it is really, really hard to read, hard to understand what to do with it, and really almost easier to just abandon it and start again from scratch than to fix things like this. But let's, for the fun of it, try and fix it. Okay, let's try and fix it. Okay, let's start from the beginning. Can we see any issues in our hash include? Or hash include looks good? Yeah. Okay. Well, hash include looks okay. I haven't really made a mistake there. What about our hash defines? Do they look good? Can anyone spot any issues with the hash defines? Yeah, we want capital letters. I agree. Okay, good. Let's change it to capital letters. And capital letters. Vertical space, I agree. If you've noticed how I code, I put spaces, a lot of vertical space. So I separate chunks that relate to each other, and then I separate them out with a space all the time. Okay, great. Int main void, this looks good. Now I've got a struct definition. Is that correct? A struct definition inside the main function? You don't need capital letters in the syntax. It's just for you to spot what is a constant. So it's just for readability. Yeah, well done. A struct definition should be outside. So I'm going to remove it and put it outside. Okay. And that's because for the same reason as your function prototypes and the hash defines, that struct is now available to anything inside inside your code, not just your main function. So that's why we declare it outside. I'm going to fix the formatting here. Anything else that I'm missing? This looks okay, but is there anything else? Anything else? Anything else? What do we think? Yes, well done. We want a semicolon after the bracket when we declare a struct. Okay, excellent. And then I'll fix the indentation for it as well. Okay, excellent. Very good. Let's continue. I've now got an enum inside my main. Should I have it inside my main or outside my main? Yep, well done. So enum for the same reason should be outside, so it can be available to everything, to all of your functions. I'm going to move it outside. Okay. Now tell me, is the format, the syntax, the format, no, it's not syntax. Is this enum declaration okay, this enumeration? Yep, good. So we need a semicolon after the curly. Well done. Anything else? And this is something that I've been forgetting to do, but inside your enum, our style guide at 1511 says that we need to do capital letters, okay? Because these are really enumerated constants. So we're going to do capital letters inside here as well. Okay, and then space after ice cream, okay? Excellent, okay? Anything else? Now I've got a struct called ice cream and an enum called ice cream. What do we think of that? They can be line by line or they can be like in a line. It depends. Yeah. I can have them like this as well. Oh God. I can't, not just typing, I can't even do an enter. Okay, what's next? Change names, I agree. Just don't spit at me, Sophia. Okay, let's change the names. This one is really flavor. Oh. Okay, any day now. Okay, good. Semicolon. Yep, good. Or flavors. That's even better. Good. I like that. Excellent. Let's continue. Let's go inside here. What else should I fix now? I'm going to move everything off once. Okay, I'm going to indent it to be able to spot what's going on easier. I'm just going to move everything and then we can start fixing it from that. Okay, I've indented. Now this definition here, is this correct? I'm making a variable of type struct ice cream. That's correct. My variable name is B. Yeah, that's correct. B is pretty rubbish. Let's call it something else. I don't know what I meant for it to be. Maybe Bill. Yeah, it looks like Bill because over here I'm accessing an element. Okay, excellent. Then I've got a int x is equal to 0 with bad spacing. I'll fix the space. I don't actually know what x is. Could be anything. I'm going to fix the indentation here. Let's fix the indentation first because that's the easiest thing to do. And it makes it easier to then see what's going on. Let's fix the spaces and the indentations. Okay, so going through it to fix the indentations. This is horrific. I'll fix the brackets. I feel like I'm missing brackets. Anyway, we'll just go with it. I don't know what's going on here. Let's fix the spaces. Okay, and then whatever you see, just shout out to me on the chat. Don't shout at me. I don't like being shouted at. Okay, here we go. Okay, so tell me the line that you see an issue with. There is just a lot of brackets that don't make any sense. I think I've got an extra bracket. Okay, let's go here. We've got a y is equal to yf. What do we think this y is actually doing? I don't know what this yf is doing. I think this yf is scanf, yeah? Which means that this should be keeping the return of the scanf. So I'm going to call it scanf return, and that means I'll change this one to scanf return. Okay, great. Excellent. 47 needs consistent spacing. I agree. That is horrific. Okay, so we've now fixed this YF. This Y doesn't make any sense now, so let's make it scanf as well. Scanf return. And we'll put some spaces in there as well to make it nice. Okay. Someone's saying, oh, yep. That was a fun one. Char loop. Yep. Whilst loop is equal to yes. Printf starting. Printf, what flavor would you want and how many scoops of that flavor? Yeah. X is price. Let's do it. Now yeah, okay. Price is just going to be an int. Okay, we'll just go with that. Should it be price or is there price already inside a struct here? There is a double price inside struct. I think this is where what do I use this one for? What was it? Was it X? It was X. I use it to sum the total of my bills. So maybe let's make this a total. Okay, how's it feeling right now? Should we see if it runs? It's not going to, but let's see if it runs because I'm starting to run out of. Okay, just a few things happening here. Look at how many errors we get. Amazing. Okay, let's go through and fix some of the easier things. Okay, this is scoop cost, which I've called something else, one scoop over there. And this is, see why it's easier to have them as big letters. It hurts me a lot. I really just want to abandon it, to tell you the truth. But anyway, let's try and fix it a little bit more. Should we fix it a little bit more? Or should we call it a day? How are we feeling? Let's poll that. This is what happens when you've got bad code, right? It's easier to abandon it than it is to fix it. I'm sorry to say. Oh, someone still wants to fix it. So when you're doing your assignments, we look at your code, okay? And if your code looks like what my code looked like in the beginning, it makes it very difficult to read, which makes it very difficult to give you marks. Do you know how when you were at school and the constant mantra was always like, if we can't read what you wrote for this essay, we're not going to mark it? Kind of similar for code. If we can't read your code, we can't really mark it. So no matter how much we want to give you the marks, we can't because we don't know what on earth you're talking about. So please, is this the same with children? I think sometimes, but you can't give them back and start again. So you've just got to try and, you've got to keep trying to fix it. Okay, and usually you're the one that stuffed it up, so it's your fault. Same with code. Fix it, and then we can, move on. Do you just run it through 1511 style? 1511 style is going to absolutely break, I reckon. Tom's about to give the command for auto testing style for the assignment. Be careful though, because 1511 style doesn't pick up, variable names and nested if loops. Well, sometimes you're nested, but yeah. Oh, you want to see what happens? All right. This is really going to hurt my feelings. Okay, don't forget to scroll up to see all of it. We're doing it. Here we go. Here we go. Okay, no ZID in the header. That's okay, I wrote my name. The close curly brace needs to be on a separate line. Okay, great. Just like I did over here, but not over here. Then what's going on here? Let's have a look. White space, you had a close and a curly with no space. Excellent. Another indent error here. More indent errors here. Okay, so indentation is a place where I need to fix things. White space, I still need to fix things. Oh, that's not really that bad. It really hasn't pulled up half the things that are wrong in this code. Wow, it's letting the team down. I thought it'd be a lot worse than that. I should have run it at the very beginning when it would have yelled a lot. Okay, how are we feeling on that poll? It's like half-half. Some people are saying keep fixing. Oh gosh, they really want to see me sweat and struggle. Tom's making these sorts of motions at me. It said some errors have been suppressed. Yeah, I made it so sad it had to suppress its feelings. Yeah, it's because there's a lot happening here. A lot. This is just terrible code. Oh my gosh, it hurts my feelings. And I went a little bit to town, I think, because I really don't even know what's going on now, what I was trying to do in this program. Yeah, let's abandon it, because we can spend our time better by writing some more code. What do we think? Where are we at? Still 61% of people that want to fix it. My goodness. Tom, can you show me the poll? Please, thank you. Oh, wow. Wow, so many want to fix this. Well, if the crowd demands, the crowd gets what it wants. Let's try and fix it a little bit. Did I eventually get ice cream last week? I don't know, can you tell from this program if I did or did not? Yeah. Okay. Let's look at it then. Okay, so let's see what I'm trying to do. All right, we fixed these ones, the enums and the structs, excellent. Now we've got an ice cream bill here. In total is equal to 0. We've initialized the variable. We've got a char loop is set to yes. Don't forget the yes is in little single quotation marks to say it's an ASCII character. And we've got an in-scanf return. Now we're saying that bill.price. So that means I'm assigning into struct ice cream, I've got a variable called bill, into its price member. So bill, and this is something that we got wrong in the Kahoot. So I'm just going to put a comment here so that we know. I am assigning to the bill structure the price member gets the value 1 scoop, which is up here in my hash define. I know that because it's capital letters, and it's 1.25. So that means it's going to get the value 1.25. So remember what this means. It means that when this line over here, line 32, runs, what happens is a structure is created. Okay, so it creates this variable, and inside this variable is 3 things. Let me just go back up. So my struct has 3 things in it. This is my struct ice cream. And it has 3 things: double price, in scoop, and char flavor. So double price, in scoop, and char flavor. So when I get down to this line 32 here, struct ice cream bill, that's what's created here. So this is called bill, this variable. And then when I want to put things inside this variable, that's when I start assigning things. So when I do bill.price, what it means, the dot means I'm going to access the price. The price is over here. Okay, so I'm going to go inside here and I'm going to assign the value of 1 scoop. So 1.25 will get assigned in here. So this is my price, this is my scoop, and this is my flavor. Okay, great. Assigned. Excellent. Let's continue. Let's see what else is happening in this program. Whilst loop is equal to yes. Is this correct here? Yep, it is, because it's a double equal sign to check equivalence. And so I'm checking if this character is set to yes. If it's set to yes, if it's true, then I'm going to go inside here and I'm going to printf starting. Then I'm going to printf what flavor do you want and how many scoops of that flavor. Okay, then I'm going to scan stuff in because I've just asked the user for some information. So I'm going to scan in a %C and a %D. And it's going to put it inside at bill flavor. So whatever the user puts in, what I'm going to go is I'm going to put it inside add bill flavor. So the first thing's going to go in here. And the second thing, add bill.scoop, is when I access this member and put it inside here. So if over here I have entered as the user, I don't know, oh God, D, that's a terrible D, just ignore my writing now is going as well. So if I do D and 3, what it's going to do is bill flavor is going to put a D here and bill scoop is going to put a 3 here. Okay, then I'm going to check that 2 things were done, 2 things were given to me. I'm going to check if scanf return is not equal to 2. I'm going to give an error and then I'm going to quit the program by returning 1. The return just means exit out of this program, and I'm giving it a 1 to say that things were not going that well. It was not a successful finish. So the 1 will mean I haven't finished it successfully. I'm just exiting out of it. Okay, now we've got this X business and this was the total. So let me return it to total and let me put a total over here. Okay, and we've got total is equal to total plus bill.price, so whatever the price is of 1 scoop, because that's when we are assigned it on line 38 over here. So well, this is going to be your 1.25 times bill scoop. So how many scoops you actually had. Okay, so in this case, it's going to be 1.25 times 3. That's going to give you that. And then you're going to do total is equal to total plus that. Okay, now let's check if I have enough money to buy my ice cream. Devastating if I don't. Okay, I've got a little bit of a nest happening here, which I don't really want. So I don't really need this if it's greater than, if it's equal to. That doesn't really make sense. I'm going to get rid of this here. And I'm just going to say if it's greater than or equal to budget. Should it be that? No, because if it's equal to, that means I can afford it. Well, yeah. Then I'm going to say printf. You do, that's a too high of an indentation. I'm going to return it by 1, return it this one as well. So you do not have enough money to buy this much ice cream. Devastating, sad face. Then I'm going to return 0, put the semicolon there, else I'm going to say, yay, you have enough to get some ice cream. Fantastic. Okay, that really captured my equals, because if it's equal to or less than, it's just going to go into my else, because it's the only other possibility if it's not greater than. So that's fine. And I'm going to do all of this on repeat in the loop whilst it's equal to yes. Does else have to go on the next line? Yes. Why is the return 0? Oh, you're right, it shouldn't be. So if I don't have enough money to buy ice cream, I'm going to exit out. So I'm going to return 1 because something hasn't finished successfully. Yeah, you're right. Very good point. I'm just so excited about... Need ice cream after this. Okay, space before %C. Absolutely, that's a really good one. What that space will do is it will pick up any white space and ignore it, which is what we want to do. Yeah, so Tom, exactly what Tom said. The program will exit with a return 0, but it will think that it's done it successfully. But we want to tell it that something went a bit astray and you've spent all your money on other ice cream and now you don't have enough for this ice cream. Okay, now I'm closing my while loop. One thing that you can notice is I have never actually updated my loop variable. Should I be closing my loop here? I don't know why I'm doing a horrified face. Yeah. Should I be closing the loop there? What do we think? No, I shouldn't be. I agree. Because otherwise I'm never updating my variable. So what I'm going to do is I'm going to print out, would you like to try ordering more ice cream? Because what if I'm still on budget and I can keep going? And what I will do is I'll scan in a yes or a no here. And I'm going to put a space here as well to capture any white space. Any mistakes here, or is this scanf statement correct? Is there anything missing in here, or are we all good? Yeah, the budget, I think, is my hash define over here. Excellent. So I'm going to change all of these budgets to a capital budget. because it's denoting that it's using a constant for this. Well done. Good pickup. And well done. Ampersand is missing here. So I'm going to pop an ampersand in here because I need to do it as part of my scanf. So now I'm going to say scan the next thing in and then go and check what is it. If it's still yes, then I'm going to keep trying. If it's no, then I'm going to exit out of here. And I'm going to call it a day. Where's this for? Where's this curly for? Can anyone see? Something's going not right for me. I've got an extra curly, I think. No, I don't. No, I don't. Okay. Like the brackets. My home one, the brackets are yellow when I'm missing something. That's why I'm having a field day here. I'm using a different theme at home. Okay. Let's have a look. Should we try running it? Let's try running it. Let's see if it will give us anything. Could we have fixed it to that extent? I don't know. Oh my gosh, we fixed it to the point that it's running. Should we try running it and see if it's actually doing anything? What flavor do you want? And how many scoops of that flavor? I'm going to say I want D. I've never used an enum as well. You know, that was just a waste of time. And 4 scoops. Yeah, you have enough to get some ice cream. Would you like to try? Yes. What if I say yes? And now I'll say I want S and 4. I still have enough to buy ice cream. Something seems to be going very wrong here. I'm going to go R and 5. And then it's just going to say, oh, I put the wrong thing in. That's why it's doing that. Okay. But something doesn't feel right, does it? No, that could work. Okay, try that again. I mean, the whole thing makes no sense, so don't. I'm going to do yes. I'm going to do 3 scoops. Oh, that's swapped around. There's a lot of errors that are not being picked up. What if I say more and I say 5 more scoops? S5. Okay, so now it's calling it for me. It's saying too much. Yeah. Okay, and what if I run it and what if I stop the loop? What if I say no here? It will stop the loop. So it seems to be something is not quite good and people are saying update the value of budget. Budget is a hash define. So I'm just checking whether the total is greater than or less than. Maybe it is right. Maybe I just can't multiply in my head. And I haven't really used the enum very much at all. I actually haven't used it at all. I've just declared it, defined it, but I haven't used it. So potentially I did not need it in here. I just stuck it in for funsies. Okay, I can't believe we actually managed to get it running. I really can't believe it. It's you should all feel such a sense of achievement that anything happened here. And let's quickly run this. I still have a few errors that style does not like. 2 things, just my usual error. My usual error. Okay, what do we think of this? Oh yeah, someone's saying, yeah, budget minus total. I mean, I keep adding to the total. Do we feel like it's wrong? Let me make a much easier number here, not 125. Well, 4 ice creams will give me $5, right? So if I do 4 and 4, I'll really run out. So there we go. Let's run it. Let's do 4 ice creams. I'll go again and I'll do 4 ice creams again. And then what if I go again? And then this time I'll go, I want, yeah, okay. So it's doing it. Yeah. Because that's my $10 worth. How's everyone feeling? Style, no style? Okay, let me check if my Safari can run for the Kahoot. We'll go over the Kahoot and then it'll be really time to finish. Okay, any questions? Pop them in the chat. Everyone's just slowly drifting off, I think. Drift, no drift? Tom's indicating he's going to go to sleep for a little bit. No. Okay, let's go look at the Kahoot. I've managed to get it working. Oh, someone wants a for loop. Oh, I could do a for loop. Should we do a for loop? And then I'll go through the Kahoot on Wednesday? Oh, okay, let's do a for loop. Democracy. Okay. Paul. Fours, no fours. I'm going to do it because it'll take like 5 minutes. Okay. So far you've learned about a while loop. Actually, I think I even have it in my lecture notes, the for loop. So we've learned about the while loop. You can also use a for loop. Okay, it's the same thing, right? Don't get stressed. If you want to, you can just use while loops the whole time and never change. Okay, if you want to, you can use for loops, and well, for loops, there might be some issues, but you can use while loops for anything you want. Okay, you really don't need to ever, feel like it's not enough. Which one is easier? Oh, Tom, you nailed it. Which one is easier? I'll tell you what. Yeah, I use a lot of for loops, and I retrained myself for ages to use while loops, but I will still often slip into for loops. So, yeah. Basically, a for loop, okay, I wrote a whole statement here why you would use a for loop, and it was so much fun. Where is it? Here it is. Okay, for loops. Okay, you want... Okay. Usually the rule of thumb is if I don't know the number of iterations ahead of time, I'll use a while loop. But if I know exactly how many iterations I'm going to do, I'm going to use a for loop. Okay? What that means is when I iterate over an array on Wednesday, I can use a for loop easily because I know the size of the array. I can use a for loop when I know that the loop should go around 3, 4, 5 times or however many times. But then I'll use a while loop. Something you don't do in 1511, but you will do, is when you're reading a file into a variable, so don't worry about it, but it's something that I would use a while loop for. I'll use a while loop when I ask for user input because I might keep asking for it. I don't know how many times they'll give me input. And I'll use a while loop when the increment value is not a standard increment as well. In the end, it's your choice. Don't get stressed about it. You don't ever have to use a for loop if you don't want to, okay? It's really not a problem. So if I write a quick program, okay, that's using a for loop, let's say it's going to go over, I don't know, what should we do? The pressure is on in my 4 minutes. It's not 4 minutes, it's 6. You liars, you just wanted to use the for keyword. Okay, you can absolutely use while loops for arrays. You can use a while loop for everything. You don't need to use a for loop if you don't want to. Okay, I'm going to have an int I is equal to 0, and I'm going to do it both ways, okay? So that's my loop control variable there. And now I'm going to loop, let's say, whilst I is less than 4, okay? What I'm going to do is I'm going to print out, the I, and new line, just to show you what it does. And then, of course, I'm going to increment my loop control variable. So I'm going to update it to change it. Remember the I++ means that it means I plus 1. So my new I becomes I plus 1. Okay, great. And then I'm going to return 0. So let's see what this does. And then we're going to change it into a for loop. So I'm going to save it, save. The pressure is on. Here we go. DCC for loop. .c, could I have named it anything worse? For, oh God, it's FPR. I forgot to do something. What did I forget to do? I've got more, I forgot to actually give it a variable. That is excellent. Here we go. And I do have some red marks on the screen. Thank you, Tom and Sophia, for pointing it out. Let's try it again, and we'll run it. Beautiful. Because I can't spell today, it's called FPR, and it's going to print out 0, 1, 2, 3. Fantastic. How do I do it as a for loop? So what I'm going to do for you is I'm going to comment out my while loop so you can see how it was done as a while loop, and we're going to talk about a for loop. In a for loop, what I'll do is I'll use the keyword for. Then inside my bracket, the first thing I write is my control loop variable, what it is initialized to. And I'm going to have an int I is equal to 0, which means it starts from 0. Then the next thing is the condition that I keep going until. So I is less than 4, my condition, and then what to do at the completion of the loop. And I'm going to I++, because when I complete, what I want to be doing is I want to be incrementing it by 1. So in the while, we had 3 separate statements for it. Int I is equal to 0 outside the while loop, the condition as the expression in my while, and then inside my while, I update the increment. In the for loop, I have an int I is equal to 0 as my first statement, comma, the condition, how long I keep going for, and then my, what should I do at the end? And then I just type my printf, and I'm going to do a %d, new line, and an I, which is what I wanted to be doing, and done. And then I'll save it, and then I'll run it. I forgot to compile it, so I'm not really showing you something. I forgot to save it. I'm having a field day here. Let's try that again. Let me clear this screen and Brussels sprout. What am I doing here? Where have I got a previous definition of it? Oh, God. Did not mean to do that. I just mean to save it. And let's try it again. Here we go. So I commented instead of semicoloned it, and FPR, and voila, it does the same thing. So that's the difference between the two, while and for. And you can use whichever one you want. It's really not a problem. It's, you know, have fun as you would with for loops. So just to go over it again. Oh, look, I made the same mistake here. I'm obsessed with commas. That should be a semicolon. I'll fix it. So we've got initialization, so what it is before the loop starts, then how long are we going until, and then what we do each time. Okay, great, well done. Tom's having a few, you can just do one more, Tom, you know you want to. All right, so that was the for loop. And here oh my gosh, again, I forgot to do a semicolon. So just, yeah, you know how it is. I'll fix it up and re-upload the lecture notes so that you don't get confused. Okay, any feedback from today? Please let me know in the in this. I do use the feedback very much, so I do value it a lot. So please, please provide feedback. Also, I just want to quickly mention, I've got 1 minute. This is usually the spot or the point in time in this course that everyone starts to think that things get really, really hard, okay? This is where things might get a bit more confusing. There's a lot more concepts to put together. Please don't, don't worry, okay? Everyone around you is also finding it to be quite difficult. It's okay to find it difficult. That's how we learn. You have your lab times, you have your forum, you have the help sessions that are starting tomorrow. You can see the details in my announcement, and we will also put another announcement once the timetable is detailed and is there. Please, please, please ask lots of questions. There is no such thing as a stupid question. every question builds your understanding, no matter how small you think that question is. Sometimes it is the smallest thing that's throwing you. So it's really good to ask every possible question because it means that you'll really get it. So please don't worry. This is the point where things start to get a bit harder. This is the point where we start rolling out a lot of help sessions to try and make sure that that you get seen, and use your lab times. They are there as well for you to get some time with your tutor and your demonstrator and ask them questions one-on-one. Yeah. So I hope that everyone had an all right time today. Yay! Functions and style. Because on Wednesday, we're going to start looking at arrays, which is, I love arrays. Not as much as linked lists. It's a bit of a, I don't know. I'll let you decide what you love better. I like arrays up until about week 6, and then I really love linked lists. I really can't make up my mind. No, linked lists. I do love linked lists. Okay, anyway, but I do love arrays as well. It's an undecided sort of, unrequited love. So we'll start arrays on Wednesdays. We'll go through the Kahoot as well, so don't worry. So we'll look at all those issues because there were some while loop issues, and I will also make some example codes that look at some of the problems that people had or things that people that didn't understand. Just rearrange that sentence for it to make any grammatical sense. Have a good few days, and I will look forward to seeing you on Wednesday. Thank you for coming today, even though it is Monday, just in case you needed to know what day of the week it is. It's a good enumeration, days of the week. All right. Thank you, everyone. Oh, look at that. That's a beautiful pun. 4 really does allow you to do so many more puns. That's clearly why I did it. All right. Have a good one. I'll see you on Wednesday morning, even earlier.